hey, so tomorrow's a test, and you know what that means, it's time to start studying. Anyway, I wrote some stuff down that helps me out, and I'm going to take a video of it, of me explaining it just for all of y'all out there, so y'all can benefit from it too. So, I want to start with these equations, and I feel like these are really necessary to understand before you can get anywhere else. And Oliver kind of went over it, but not really. It's for volume, area, and a line. The Q is Q enclosed, the A is area, and that thing is an L, and this is for length, and I just do my L's in cursive. And so those are the basic equations they need to get. And of course, the Gaussian's law, you already know that. And then the way I like to think about it is how to find the Gaussian surface. So if you're given a line, the Gaussian surface you need to make is a cylinder. If you're given a plane, you need to make circles. If you're given a dot or a sphere, you can make a sphere around it. And then, so that's the basic stuff they need to know. And the last thing you need to know is that, which is helpful. I don't think it's that necessary to know, but it's helpful in simplifying some stuff. So I'm just going to start going over some things, starting off with these equations and applying them. So if you're given a line, you want to make a cylinder. But if you're trying to make a cylinder around this line, here's a picture of it that we did in class. You need to make a cylinder around it, but in order to have a cylinder, you have to have a length, a distance length, but you don't really want that length in your answer. So you need to know that L is bad. Like, you don't want to have an L in your answer because you're trying to find out some point that's on the cylinder. You don't really want to think of it as a cylinder. You just want one little point on that. So in your final answer, you want to try to get rid of the L, and that's important in simplifying these things. So we start out with the basic equation. You go out with the area. That's just the surface area of a cylinder. Remember, we're not using the ends. We're just using A1, which is just this surface area. It's not the ends. So dA would be 2RL. Then you remember this equation over here. These equations, you sub out Q for that because this is a line. And then so you just bring it over and the L's cancel. So that's why I needed to know these, because otherwise your L's wouldn't have been able to cancel and you would have an L. And remember, whenever you're doing this, that L's are bad for cylinders. So basically, anytime you're given a cylinder, that's what you need to know. A further way you can simplify this, which is what one of our worksheets does, which is kind of weird, is it simplifies it to this. So you go from here to here. And basically what they did was, remember this guy over here, they just said because you have 2 pi epsilon naught, you can just times it by 2, and then you get 2 times 2, like basically what they did was they multiplied it by 2 over 2, so you get 2k. Y'all can see that. Anyway, so that's a line. Say next you want a plane, and you make circles. So whenever you have a plane, you make circles above it. And remember, in your answer, you don't really want like a circle. You don't want to think of it as a circle. It's just this plane that's above the cylinder. So you want one little point on that circle. You don't want the whole circle, so R's are bad. So when you have a plane, you want to make circles. R's are bad. You don't want an R in your answer, so we need to get the R out. In order to break up this Q they start out with, you need these equations over here. You need to make this Q equal to something. We're dealing with surface area, so Q is equal to canon A. I still don't know what that's called, canon A. And so you want to, that's the point of these equations, is because in a line, L's are bad. You don't want L's, so you need Q to equal something else. In planes, the R is bad, so you need to get rid of that. So dA right now is pi r squared, because that's obviously the area of a circle. Simplifies to that, like I said. There you go, divide it over, and it simplifies to this. It's kind of convenient because this A and this A are the same thing. Originally, all you needed was to cancel out the R, but it ends up canceling the whole thing because, this A and this A are the same. So pretty much you could say E over A equals canon A over epsilon naught, and the A's just cancel. So you get this. So at this point, before we go any further, you need to understand that what we just did was one circle, right? we just got this guy, only this guy. We hadn't even done this. But in order to have this guy, you have to have the one in the bottom. Otherwise, it doesn't work. It's just one isolated by itself, and it's not balanced. So what we need to do is you need to have this guy too. So what you have to do is you have to understand that this isn't a whole part of it. This isn't the whole thing. This is not the whole thing. You have to understand that, like, this is the field. You need to understand that 2 of the field equals this. Like, double of the field equals this. So 2e equals this. And you divide the 2 over and it gets this. I don't know how else to explain it other than visually. They have to have the bottom and we have the top. So that means if you're just looking at the top, that means this is twice of the electric field. So again, 2e equals this. Divide the 2 over, you got that. Last but not least is the sphere. And in the sphere, you're trying to find, you're thinking of it as a sphere outside of it. And again, you only want 1 point on the sphere. But in order to control how far away it is, you need a radius. And so a radius is okay in this one. So it's unlike the past two, where when you needed to find 1 point on this, 1 point on this, you don't need the length of this cylinder to find out 1 point on this. So you don't want the length on this. You don't need the whole radius of this circle in order to find 1 point on this. You only need the distance. On this, all you have is the radius, so it's okay if you have a radius. So whenever you're finding a sphere, it's all good. Don't worry about it. Like, if you have a radius, it's okay. So you start off with the obvious Gaussian law, 4 pi r squared, surface area of a circle. You should probably remember that. It's okay though, because it's probably on the equation sheet. Easy. I just did this next step just because obviously we remember this equation over here. And all you do is you just make the 4 pi epsilon naught, I forgot the naught sign, sorry, into kq over r squared. So that's basically how to do that. I think I might make another one over how to do whenever you have a conductor surrounded by a non-conductor. I might make a video over that if y'all want it. Maybe, like, if I end up studying it tonight, I'll probably make a video over it just because, like, it helps me just to make these videos just for me. So if none of y'all watch it, at least I'll benefit from it. So hopefully it's beneficial. Let me know if you have any questions, and I'll try to answer them.